Hello friends, welcome to Shiksharthi. In this video, we'll be talking about Incentre under the head of geometry. So let's start. Now, we will divide this session into two parts. In the first session, the focus would be on internal angle bisector theorem along with the discussion of angles. And in the second part, we'll be talking about the sides, the length of the sides, the ratio of the sides, etc. is what we're going to talk about. Okay, so here what I have done is I have taken a triangle ABC such that I is the incentre. Now when I say I is the incentre, this is the given piece of information, which is why I am able to say that I is the incentre. I repeat, I have taken the triangle ABC such that this is the given piece of information in this discussion or in this question. Now what is the given piece of information? Angle ABI, which is this, is the same as angle DBI. Okay, so if I talk about this angle, or I could have said angle CBI, doesn't make any difference because the points B, D, C are collinear. Now collinear means that they lie on the same line, These are three different points lying on the same line. That means the slope of the line is the same throughout. Meaning thereby the slope of BD is equal to the slope of DC, which is nothing but the slope of BC. Okay. Similarly, and this we have taken it as X degrees. Similarly, the angle ACI is the same as angle BCI, which we have taken it as Y degrees. And last but not the least, angle BAI is the same as angle CAI, which we have taken it as Z degrees. This is already given. So now if I talk about the line segment BE, the line segment BE, the points B, I and E are collinear. Now you would see that I have introduced the word collinear, or I can say BIE is a straight line. So there are two ways of representing this. I can say BIE is a straight line on which there are three different points lying, and those three different points are BIE. Or I can say that there are three collinear points BIE. Okay, coming back. So BIE is a line segment. I mean, we are talking about, this is the same line. Okay, similarly we are talking about CIF. These are three collinear points, that means they lie on a straight line. At the same time, AID is a straight line, or I can say that there are three collinear points lying on a straight line, and these three collinear points are AID. Okay, which is why we are able to say that the point of intersection of these three lines, let us say the line segment BE, line segment CF and line segment AD, the intersection point of these, given that these are angle bisectors, incentre is formed. And the moment the incentre is formed, we'll be able to say that these angles, they get bisected. All these vertex angles will get bisected. As we already know that the word bisect means dividing something into two equal parts. Here we are talking about angles. When we talked about median, we talked about the length of the sides. Here we are talking about angle bisectors. Okay, so an incentre is formed because of the intersection of the angle bisectors. This is how an incentre is formed. Okay, some observations now. So the first observation is, so you will see that I have divided this into various angles. I mean, so let's say that how many triangles have been formed? 1, 2, 3, 4, 5, 6. So with the help of angle bisector theorem, with the help of exterior angle theorem, and with the help of vertically opposite angles, these are three theorems that I have used to indicate all the interior angles. I mean, each interior angle of each triangle that has been formed thereafter because of the because of the intersection of the three angle bisectors. Okay, now so this is for you to understand. I have already found it out. I'll explain one. For example, if this is angle X, this is also angle X because we are talking about angle bisector. So we start off with angle X, angle X, angle Y, angle Y, angle Z, angle Z. Now once I have these angles, I can find out this angle. Which angle am I talking about? I am talking about angle AIE. Now angle AIE is nothing but the remote exterior angle. Now when I say remote exterior angle, what I am trying to say is x plus z should be equal to angle AIE, is where I am using the remote exterior angle theorem, which is just like saying sum of two interior angles inside a triangle is equal to its remote exterior angle. And thereafter I used the concept of vertically opposite angles, and if this angle is x plus z, similarly this angle also becomes x plus z, and thereafter I have done it for other triangles also. So you can use this. So there are three theorems basically which I have used for angles. One is angle bisector theorem. Second, we have used the concept of remote exterior angle theorem. Third, we have used the concept of vertically opposite angles. To do what? To find out the interior angle of each triangle that has been formed thereafter. Right? Now, the point of observation. So, if I want to find out angle BIC, I know that I already have the angle BIC, but before that, sum of all interior angles of a triangle is equal to 180 degrees, which is just like saying 2x plus 2y plus 2z is equal to 180 degrees, which means x plus y plus z is equal to 90 degrees. Right? So, when I am finding out angle BIC, can I say angle BIC is nothing but angle x plus y plus z degrees, which is just like saying 90 degrees plus z, which is another way to understand this is angle BIC is equal to 90 degrees plus the angle bisector of angle BAC. Bisector means dividing it into half. Analogously, I can find out angle AIB also, or I can find out angle BIA, which is nothing but 90 degrees plus half of angle ACB or BCA. Analogously, I can find out the angle CIA is equal to 90 degrees plus half of angle CBA. So this was talking about the angle part of it with the help of angle bisectors. Second thing now which is important after this is to find out what is interior angle bisector theorem. So for this, I have drawn a triangle and I have just replicated these points. So I am taking a triangle ABC. This is the triangle that I have taken, and this is the angle that we had extended. This is the angle bisector of, so this is the angle, the line of angle bisector. This line BE is nothing but the line of angle bisector here. So I have extended the line B till P. So that means this line goes outside. And if you recall, we had talked about in our earlier videos also, I had talked about the importance of two P's, one S and one C. So what I have done now here is, I have drawn a line parallel to this. So the line AB, I have drawn a line AP. I'm sorry. So there is a line AP which has been drawn parallel to BC. Now when I draw a line AP parallel to BC, even before I go ahead, let us see. So we know that if this angle is x degrees, this angle will also be x degrees because we are talking about the angle bisector. Thereafter, using now these are alternate angles. So what is the concept that we are using here? We are using the concept of alternate angles. So for two parallel lines, these become alternate angles. So if this angle is x, this angle also becomes x. And thereafter we are using the concept of vertically opposite angles being equal. So this I assumed it as y degrees. In that case, this angle also becomes y degrees. So can I say angle QBC? So QBC is equal to angle APQ. Yes. Is equal to angle ABQ. Yes. Thereafter, now in my very first video on similarity and BPT, we talked about, so now let us talk about the triangle ABP. So now if I am talking about the triangle ABP, so we are talking about the triangle ABP. So we know that angle B is equal to angle P. So thereafter we'll be able to say, now inside a triangle, equal angles subtend equal sides or make equal sides. So we'll be able to say that these two line segments are equal. So we are saying that line segment AB is equal to line segment AP. Thereafter, this we have already considered. Now thereafter, can I say I can use a double A test and prove that this triangle and these two triangles are similar with the help of double A test? Yes. So can I say triangle APQ is similar to triangle, so we are talking about angle X, angle Y and the third angle. Angle X, angle Y and the third angle is similar to BQC? No, I'm sorry here. So we'll say angle APQ is similar to triangle CBQ. Right? Once we have said this, then we'll be able to establish the BPT theorem. And BPT theorem says if there are two triangles which are similar to each other, which is just like saying the ratio of their sides would be equal. The ratio of the sides is AP upon CB followed by AQ upon CQ followed by PQ upon BQ. Once we have been able to establish this, which we already know with the help of similarity and basic proportionality theorem, now we know that AB is equal to AP, right? So using only these two ratios, can I say AB upon CB is equal to AQ upon CQ? This is what we are talking about as interior angle bisector theorem, which is very, very important, and this is the second geometric center that we have talked about. So if you recollect, in my very first video on medians, we talked about there are 4 geometric centers. We have already talked about median centroid. Centroid is a geometric center which is formed out of the intersections of all the 3 medians of a triangle. Thereafter we talked about the incenter, which is this, which is formed out of the line of angle bisector, the intersection of all the 3 lines which act as angle bisectors for the 3 vertex angles inside a triangle. So because of which now we get the interior angle bisector theorem, and the interior angle bisector theorem says if this is a triangle such that angle B is being bisected, we can say that AB upon BC is equal to AQ upon CQ, and we have already proved this. Now after so many sessions of geometry, I think this is the right time to advocate that geometry becomes easier if you prove each and every theorem. Now what I mean to say here is every theorem should be taken as a question, prove it first so that you are able to take it as a question. So every theorem, you are not taking it as a theorem merely, you're taking it as a question. Now when you take it as a question and you prove it n number of times, you will take at least one attempt to prove that question or theorem. So take at least one attempt or more than one attempt wherein you are proving that theorem. So you are not only proving the theorem, you will be able to use it also effectively, because let us not treat it as a theorem, let us just treat it as a question that comes to you, because only when you take theorems as questions, it is then only you can apply theorems inside the questions. I hope you would have heard this piece of advice. If you feel that this video was really informative and this makes you start liking geometry, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some special videos on some specific topics, please put it in the comment section. Thank you so much. Until next we meet, goodbye.